Hi students, we're going to talk today about the periodic table. I'd like you to take your periodic table that looks like this. We use this one because this is the one that actually the exact one that you get on the 8th grade STAR test. So you'll have this exact periodic table with this exact information on it. So we're going to use this in our class. So I'd like you to begin. We're going to begin here with our little square. We already have seen this. We know what the things on here mean. We're going to go ahead and write ape man on here. Remember, A, atomic number, equals P, the number of protons, equals E, electrons. So this is just a good thing to write on here to remember as we're looking at these. Now remember, the atomic mass right here that we have is protons plus neutrons. So you can remember there are little drawings. That's like we've got our little protons. I like to use red for protons, and our protons and neutrons make up the mass of any atom. So protons plus neutrons are there. Now remember, man, M-A-N, atomic mass minus neutrons. Sorry, I wrote that wrong. M-A-N, M minus A equals N, right? So atomic mass minus atomic number equals neutrons. I had neutrons on the brain. So you'll have atomic mass minus atomic number equals neutrons. That's your MAN. Now we're going to start looking at the periodic table. So when we are looking at the periodic table, we call it periodic because we see characteristics repeating. So the reason we see that we'll look at a little later, mostly because of the electrons. But we're going to start with what are periods. So you can write a periodic table right up here, write a period. I like to say it reads like a sentence because we have a period at the end of a sentence. And so we can think of sentence. I can't talk and write at the same time. Period reads like a sentence. So when we read a sentence, we're reading it like this, right? In English anyway. We read it right to left across the page. And so a period also goes across the page. So these right here are the periods. So we have period 1, period 2, period 3, etc. They read like a sentence. So remember, a period is the horizontal. It's horizontal. It reads like a sentence. So the periods tell us how many electron shells are in that period. So for the first period, we have, I'd like you to draw this down the side. It's a good way to remember this. You're going to have one shell. So I'm drawing like a little nucleus and representing a single shell by making like a little bullseye there with one circle. For 2, we're going to have my nucleus and we're going to have 2 circles around it because it has 2 electron shells. 3 is going to have 3 electron shells, and so on. I'm putting them nice and close to each other. 4 is going to have 4 electron shells. 3 and 4, 5, keep going, 1, 2, 3, 4, and 5. Now I'm running out of space, so I'm actually going to just do it like this for 6. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. I'm only drawing half the circle. So it's important for you to draw these circles here because when you go to think about the periodic table, I want you to visualize these bullseyes down the side of your periodic table. That's going to help you remember that everything in this period has 4, like if it's period 4, it's going to have 4 electron shells. So that's what periods tell us, how many electron shells an atom has. Now, almost more important than periods are our groups. So a group are these vertical columns of things. So these are, we're gonna write it right here, groups. And I want you to think about, they're also called families. So you'll hear both terms and they are used interchangeably, groups and families. Now, if you think about a family, you probably look like your mom or your dad, or your siblings, you might look alike. So families tend to look alike. Say they look alike. So they have similar characteristics. Similar characteristics. So I want you to write that down. They have similar characteristics. And these are things like boiling point, melting point, reactivity. So when we're talking about characteristics, we're talking about reactivity, chemical and physical properties, chemical properties, physical properties, such as, like I said, appearance, boiling point, and then reactivity as well. So they look alike, they have similar characteristics. Also, one of the things, kind of like my period reads like a sentence, for groups, I think about like groups of friends, they like to hang together. So I think about groups hang together. And so these are your groups here, right? These are all the groups. They are your vertical groups, and they're over here as well. Zoink, right? So these are all, and these as well. These are groups as well, but we mostly are looking at these right now. So these are groups. They look alike. They hang together. So what do the groups tell us? What can we know about groups? So this tells us these numbers right here, where it says 1A, 2A, and then over here it's 3, 4, 5, 6, 7, and 8. This is the number of valence electrons. Now, valence electrons are the number of electrons that are in the outer shell. So these are I'm going to use blue for this and pointing to that. Now, you can see when you're counting number of valence electrons, you're starting here in group 1, and we say group 1, 2. We skip this section in the middle, this little rectangle section. These are our transition metals. They do have valence electrons, but when we're counting up valence electrons, we actually skip this. There is a reason for that. It has to do with the shape of orbitals. You'll get into that more in chemistry, or if you want to find out more, you can ask me or find out. But we count 1, 2, we skip these, and then it's 3, 4, 5, 6, 7, 8. So it's important to know how you can find the number of valence electrons. And that's right there. You can, if the numbers aren't there, like I said, you can count up. Now remember, valence electrons determine the reactivity of an atom. So if an atom has 8 valence electrons, then it sort of behaves as stable or full. It's non-reactive. So this group right here is the group 18 is called the noble gases. You definitely need to know that. These are noble gases. It has 8 valence electrons. I'm going to put 8 valence, val electrons. It has 8 valence electrons, and they are stable or non-reactive. So they do not form compounds with other atoms. They're noble, they're on their own, they're completely unreactive. And that's this whole group here, group 18. Now, those are the non-reactive elements on the periodic table. The ones that are most reactive are going to be the ones that have only 1 valence electron, 1 or 2, or if they have 6 or 7, they're going to be very reactive because they're going to try to get that perfect number of 8. We have something called, I'm going to turn it this way, and you can write yours, the octet rule. The octet rule means that that the outer shell, or the valence shell, outer shell, or valence shell, needs 8 electrons. I put an E with a negative because electrons are negative, so E negative is shorthand for electrons. Needs 8 electrons to be stable. So it can do this, we're going to talk about that a little later, but it can do this by sharing electrons or by donating and receiving extra electrons. But we can keep that in mind, the octet rule. You can it means that it needs 8. So if it has 1 in its outer shell, then it's going to try to get rid of that extra 1. And if it has 7, it's going to try to get 1 more to go with. So these are our most reactive metals here. So group 1, well, I should have written here, this is the alkali. I'll turn it this way so you can see alkali metals. They have 1 valence electron, Ve minus, that's valence electron. And then group 2, this is group 1. Group 2 are called the alkaline earth metals. And they have 2 valence electrons because they're in group 2. So I'm going to sort of shade this one this color. If you have colored pencils, actually, this would be an ideal time to use them here. You could kind of shade in group 1 and group 2 and label them. So now let's take a look. So these are metals. Let's take a look at our non-metals for reactivity. So again, these have 1 and 2. They are very reactive. Our most reactive non-metals, which are over here, are going to be this group 17. These are called halogens. And they are extremely reactive. They have 7 valence electrons, Ve, 7 Ve, valence electrons, and they are very reactive. And they are non-metals. So let's take a look now and see where are the metals and non-metals on our periodic table. So I'm going to use, if you have colored pencils, you can shade the whole thing. Otherwise, I'm going to outline mine. So I'd like you to notice this darkened line right here that sort of makes a stair step on the periodic table. So on either side of that line, you have what are called metalloids. So it's going to be touching the line. It's basically going to be on either side of the horizontal line are your metalloids. And these are elements with characteristics of metals and non-metals. So sometimes they behave like metals and sometimes they behave like non-metals. So I'm going to sort of outline those. Actually, I'm going to highlight them so you can see them. It's going to be aluminum, boron, aluminum and silicon. We have germanium and arsenic. We have antimony and tellurium. And we have polonium and astatine. These are our metalloids, or semi-metals they're sometimes called. These are metalloids or semi-metals. Okay? Now anything then to the right of that, over here, these are all, including the gases, and hydrogen, actually, he's sitting over here, but hydrogen is, these are all non-metals. Non-metals. Then basically everything else is a metal. So all of the rest of these, all of this, right, including these down here, these are all metals. So most of the elements are actually metals. So about 2/3 of the periodic table is metals. So these are our metals. And these are our non-metals over here. So now you have an idea where metals and non-metals are. The ones in the middle, right here, this box in the middle, are called transition metals. So this part right here, remember I was saying we skip them when we are counting up, and that includes, well, sort of. These are the actinines and lanthanides, but these are our transition metals. Transition metals. So that's a little overview of the basics of the periodic table. So the important groups to remember are your alkali metals and alkaline earth. They are your highly reactive metals. And the halogens have 7 valence electrons. They are your highly reactive nonmetals. And then the noble gases. They are also nonmetals, but they are all gases and they are completely unreactive because they have 8 valence electrons. So you've done this now with me. Try sometime on your own to see if you can look at a periodic table and label them by yourself. That's a good activity to do to see if you've actually learned it, and you can use this periodic table that's annotated that helps you understand and helps you remember the things that you know as we go through some of our activities.